So Andrew, talk about Android. Match up pretty well.
Sometimes spell type Android instead of my own name. So cool. I just thought spell type. All right, cool. So yeah, I'm going to be talking about Android or Groovy, the language running on Android. I just found a typo in my slides, but that's okay. So I'm a developer at SmartThings. That's important because our whole backend is Groovy, and you can also write these things called smart apps. They're apps that you can control devices in your house with, and that's all using Groovy DSLs. So that's kind of how I started learning Groovy. The tooling support around that was kind of painful, and at first I did not like the language. I was like, it looks like JavaScript, and I don't know what the types are and everything, but it turns out there's actually, you don't have to have it that way. There's it's actually really nice, and it's really grown on me. You can find me on Twitter or GitHub, those two places. So a little bit about this talk. So why Groovy? Java, I personally like Java. It's not a bad language. It definitely limits a lot of what you can do, where there's a lot of work you have to do to be able to get a really simple task done. But there's nothing inherently wrong with it, so why move away and try Groovy? And then how to get it on your Android project, and then go over some cool projects that are actually out there already. And then finally I have a sample app that we can look at and kind of show off some cool features. How many of you used Groovy before? I'm guessing most of you had experience with it in Gradle at least. Cool. So what is Groovy? It's not just a dynamic language, which is like what pops to people's minds most of the time. It's a multifaceted programming language for the JVM. So what does that mean? It means that it's extremely flexible. You can have type checking, you can actually have static compilation, or you can have it be dynamic. So you have all of these options. This is just copied from their website, so it has really nice features that you can use, and just show some of those off. So this is Java. As you can see, this is pretty verbose for adding 3 names. Hopefully you guys can see that. It looks kind of a lot smaller than I expected. So there's 3 names getting added to a list, and then we print them out. It's pretty verbose, so let's try adding Groovy to it. All that we really do here is remove the semicolons, and then you don't need the parentheses on your method calls. They aren't required. It's not really, there's certain spots where that comes in handy. Use it as you will. And then another big chunk that's missing here is the system.out.println. You type println all the time. Why type all the extra stuff? So it's not very different at all. And in fact, most Java code will just run if you paste it in as a Groovy file. But we can do better. So here's the same code snippet. It does the same thing. Better list support. So now I don't have to write a new list and then add each thing individually. You can just make a list and put items in it. This is now def, which is basically just an object in Groovy. Here we know that it's a list. So my two cents on def is use it, but don't return from your methods with def, or don't take in def, because then you have no idea what, if I go to and see your method signature, I'm like, it returns something and it takes something. I have no idea what though. So unless you're going to write that all out in comments, try to type them. But I really like it in methods inside of my own private methods or whatever, because let's say I wanted to change this to a map or something like that. You don't have to go and redo the whole 2 sides. It saves a little bit of work. You can change things pretty easy for refactoring and everything. The other thing to notice about this is there's an each on here. So this is a function call, so there would be parentheses here. This is one of those instances where the optional parentheses is really nice. You don't have to put them there. So Groovy has a really, really nice collections API. It extends off of the Java ones. You have each. There's find all. I did something in a Gradle file the other day where I had to parse a huge list of strings, cut them, add a semicolon in between them and all this stuff, and I was able to do it in one line of code. So there's some really nice collections API things that you can do. On top of that, so maps are very similar. You just add a colon in between your objects, and you end up with a map. So that's really nice. So another reason to use Groovy, why you might want to switch to it, is this is a immutable object in Java. I couldn't even fit it all on the slide. I just put comments where that stuff would be implemented. It's a lot of work to do that, and it's very error prone. Like a lot of times I use my IDE to generate a lot of these equals hash code and toString methods. But if I add a new variable or a parameter to this, like you could forget to add it, and then your hash code doesn't work anymore, or actually more importantly, your equals doesn't work anymore. So it's very error prone, and it really sucks. So what does that look like in Groovy? Immutable. Add an annotation to it, and we're done. It's that easy. So another cool thing that I thought I'd bring up, since I had all this extra room, was this could be basically the Java object constructor. It's a person. If somebody had two first names, though, you wouldn't know, like, this is the first name, this is last name. Maybe I, for whatever reason, took the last name first. Groovy has a map that can be taken into the constructor, so it just gets mapped to these, and then this whole object, like the constructor gets generated, and we'll take the first name and set it to that, last name to that, all done for you. So this is called AST transformation. It generates code at the compilation process, and it's really nice. You can do some really cool things with it. And Groovy has a lot more too. So another reason, button presses. Yeah.
Can you do that with normal methods too in Groovy, or just the constructor?
If you have a map on the method, you can do that, and generally your IDE is going to actually be able to tell you those. So yeah, it's pretty nice.
Can you programmatically access that map?
Yes. Yeah, maps are really, really flexible. So button presses in Android, Android, you have anonymous classes everywhere, and it gets really confusing, a lot of work sometimes. It's just messy in general. This isn't terrible, but I know I've taught some people Android, and they were like, how do you set a button press? Like, why isn't it just this equals this or whatever? They're coming from a different language. They didn't know about anonymous classes. And so this gets kind of confusing to them. In Groovy, just becomes this button on click listener equals, and then this is a closure that we're setting it to here, and you just do all your work inside of that. So it doesn't really save you all that much typing, but it's a lot more readable, like this thing equals that. And then here, this is like, I don't know how often you read or write files in Java, or in Android, but it comes up every once in a while, and every time I have to do it, it's a pain. I have to like go Google it, and I'm like, oh man, that's so much work. And then you have to remember to close your the streams, and this one's not even closed properly, so I'm pretty sure you're supposed to have to try catch around it. Even though if it can't be closed, there's not really anything you can do, and it gets really, really, really tedious. And the Apache Commons library helps, but it's not great. On top of that, yeah, like there's just so many different ways to do it too. Every time I Google it, there's like 5 different ways that I've seen. So what do you think that looks like in Groovy? One line. Does the exact same thing as that other whole block of code. And actually, you can do the same thing with URLs. So if you want to get something from the web, you'd have to, again, do tons of work normally without any libraries. That looks like this with Groovy, and to run it, that's all I had to do. I got a whole web page printed out on the screen down at the bottom here. So it's pretty powerful. And some other reasons to use Groovy. So you have DSLs. If you guys are familiar with Gradle, you use DSLs all the time. There's that application goes further. Like I've seen people try to write builders. There's in Groovy for Android views, which is really nice. Extension methods, that's something I wish Java had, because that's why we end up with all these utility static methods everywhere. With extension methods, you can now attach something to the object. That's similar how that .text worked on the URL and file that I just showed. It's just an extension method that does all the work inside of it. It's not a file object, it does the work for you instead of you having to write some utility method or some other just big block of code. There's more operators, which some of my favorite are the as operator, which will take your object and try to cast it to something. If it doesn't cast, it returns null rather than throwing a null pointer exception like a normal cast would. Then there's also the Elvis operator, which is a question mark colon. It just drops part of your, normally you'd have like a, if this thing equals null, question mark something, colon something, it just drops the first part. And so if it's true, it just returns that value that you were looking at, which is really nice. And then there's also safe navigation, since null pointer exceptions happen all the time in Java. With this, you do question mark dot, and then if the thing is null, it won't try to access that method, and then you don't have to worry about checking if the object's null first. Oh, operator overloading, generally not like something you probably are going to do on Android too much, but it can be really nice. I do have an example of that later. So you want to make pluses on some new object you made. Instead of having an add method, you can now actually write it in a very mathematical, like meaningful way that you can see two objects are getting added to each other. And then lastly, AST transformations. You saw one with that add immutable. There's so many other applications for that. I'll show some examples of those later as well, but that just hooks in at compile time. I don't know if you guys are familiar with Java annotation processor, but that generally generates an actual full-on Java file for you. In Groovy, instead, it actually hooks in at the compilation process, and you can actually write your code right in there, so you don't have to generate a file and then use like reflection or directly access a generated file, kind of like Dagger or some of those other libraries do, which is really, really helpful. So how does this work on Android? So the general compilation process is you have some Java file, gets compiled, goes to a class file, then you have it run through Dex, which then puts it in an APK file, and then you have the runtime. Fairly straightforward as long as you don't have to actually do any of that work, and there's a tool that does it for you. So with Groovy, it's basically the same thing. We have to take the Groovy code, compile it to Groovy file, or run it through the Groovy compiler to get the class files, and then basically everything else happens the same, more or less. Groovy does do some generation at runtime of classes and some stuff like that that isn't really practical to do on Android. It's either slow or there's certain things that just won't work. So most of this is focused on static compilation. So if you actually want to get, or some of the problems with getting it on there is the bytecode's different than the JVM bytecode. Android has the Dex bytecode. So yeah, there's no native support for generating classes at runtime. This is a big one. The java.bean package is missing on Android since Oracle decided to make that proprietary, I guess. So the way around that is actually Google has a library called OpenBeans, and Groovy, as it's compiling, will actually switch all of the Java bean properties with the OpenBean. So all the import statements to that, and everything works fine. But because of that, there's a customized Android jar file. So there's multiple runtimes on Android, which is kind of a pain, and it doesn't always behave the same as the JVM. So getting it to work on Android, Cedric, he was the one who got it to work. He works at Pivotal right now. He was also the person that got static compilation working and some other really awesome improvements to the Groovy language. He's a core contributor to it. He created something, added the Java bean replace, and then it sounds like there was a little bit of tweaks in Java or Groovy 2.4 that allowed it to work on Android, which is pretty cool. And it both works with static and dynamic runtimes. again, I would stay away from dynamic, but it does work and it's really cool. He has actually, Cedric has a sample application where it actually lets you type in Groovy code and run it. It takes a really long time, but it does work. It's pretty amazing. So if you wanted to get this into your Android project, all you have to do is add this plugin, and that was written by Cedric. And right now it doesn't work with the 1.1 Android plugin, or there's not a release yet. It'll be coming in 0.36. So you're going to be stuck on 1.0 release for the Android Gradle plugin. And then finally, you have to add the Groovy jar to your dependencies, and now you can run Groovy. You just add another folder for the Groovy files, and then you put them in there. Android Studio doesn't have support for Groovy files yet, so I generally make a Java file and then just switch the extension on it to Groovy, which works pretty well. And then you don't have to put it in main. I actually use Groovy mostly for my unit tests, so Android tests. That was actually what got me interested in Groovy, is that the JUnit 3 tests really, really suck. And so Groovy alleviated some of that pain. It wasn't great, but it's better. So some projects that you can use. Another problem with Groovy is that a bunch of the annotation processors from Java don't work really well because they can't hook into the compilation process the same way. So Swiss Knife actually combines a bunch of those annotation processors into an AST, or a bunch of different AST transforms. So if you are familiar with Butterknife, Android annotations, and Android autoparcel, it kind of brings all of those together in one big awesome jar file. Uses a lot of AST transformations, and then there's some awesome extension methods as well. Logging on Android can be a pain, it's all static. And there's some other just kind of things that you're like, I wish I had this object, but I don't have it. They add it using extension methods to I think there's some that are added to the context. There's some that are just added to all objects where you just have access to some really nice methods. So here's an example of Swiss Knife. So for parcellables, the string will now get saved, gets restored down here in the restore state. There's the onClick, which is very similar to Butterknife's onClick, so you don't have to write onClick listeners. It'll just kind of do it for you. Then background threads, instead of having to run an async task, you can now just tell this, use this annotation, and this method will get executed on the background thread, which is really convenient. And then this is kind of just the setup. You still have to call Swiss Knife inject and Swiss Knife restore state, similar to the other applications, other libraries in Java. So I would normally just stuff that in a base library, or base activity, base fragment. So this kind of is also another reason to use Groovy. Writing parcellable in Java would look like this. So in fact, it doesn't even fit on the screen. There's more. Scroll down to get it all. And this is also very error prone if you forget to add something to write out state. So you add like a new property. Really easy to forget. In Java with Swiss Knife, this is all you have to do. Add the annotation. You're done. Something I failed to point out earlier, actually, is Groovy auto-generates getters and setters for you. If these are marked final, it'll only generate getters. So that's why I don't have the getters and setter code here. But yeah, it's auto-generated, so you don't have to think about it. So another library, and this is one that I maintain, is Spock for Android. All it really adds is mocking support for Android, since it uses generating class files at runtime. It uses, I think it's like DexMaker is what it's called. So it just swaps out Genesis with that. And then there's some useful extensions. This is actually what got me really interested in Groovy. I was talking, and I'm going to be doing a talk at GreatConf about how this works and how it kind of came about. But basically I was using Groovy for my JUnit 3 tests. And I was like, this is pretty cool, but I wish I had Spock on here. And I like tweeted out about it, and Cedric said something like, why not use Spock? And I was like, oh, I should try that, and it turns out there was just a couple of issues, but it worked through, and now it more or less fully works on Android. I'm still working out some of the small bugs. But if you're not familiar with Spock, it's a unit testing framework. Still, it builds on top of JUnit 4, so you can still use JUnit 4 tests like you normally would. But you get these really nice methods instead of like the kind of cryptic methods or using like underscores to define a method to tell what that test is supposed to do. You can actually just use strings, which is really, really nice. Then you have power asserts instead of saying like assert that this thing equals this thing, or you know, whatever assert library you use. You can actually just use, you know, not equal or double equals, and it'll throw an exception if it doesn't work out, and it gives you a really, really nice message of like this activity, you know, it a little arrow, like this activity is null and it expected, you know, not null and stuff like that. So it's really nice. And then here's the example of one of the extensions that I added. So you just annotate your object up here, and when this test gets executed, it'll actually create this activity and just give it to you, so you don't have to do all the work in a setup method. So this is an application that I wrote based off an iOS app called Circle Stack, written by one of my coworkers, and you drop circles on top of each other if you're and they expand. As the circle expands, if it goes outside of the last drop circle, you lose the game. Every circle you stack on top of that, you get a point. So I wrote this thing, rewrote it, or ported it to Groovy, and just thought we could go over some of the stuff to kind of show off some cool features. So right here, you guys see this? I like emo mode on IntelliJ, so I apologize if you can't read it. But this is just showing off the as keyword. I run into this every once in a while using Guava and Butterknife. They both have optionals, so you have to fully qualify one or the other, which is a pain. But if I was using Groovy instead, I could just say as something else like Butterknife optional, and now you can just refer to that, and you don't have to worry about fully qualifying anything. Here's the inject view stuff. That's pretty simple. Nothing really fancy there. So, since Groovy has auto getters and setters, this is calling set content view like you normally would in an activity, but it's nothing really special, but it does show that this is more readable. Content view of this activity just equals that layout file. And here's the name of the constructor, which is really cool. And here's where we get into some of the, I wanted to show one more thing I forgot. Compile static. That's the annotation you would add to your class activity that you want to be statically compiled. This is strongly recommended to do to make sure your application runs fast. It probably will run fast on some of the modern phones, but if you ran it on an older, you know, the 99-cent phone you got from AT&T, it probably wouldn't work out so well. You're really slow. So because of the mapped parameters on a constructor, this is really readable. You can see that the X value I want, where it's coming from, the radius I want for the circle, and the context. It's clearly defined. And I just save them into a map because I'm going to actually use those parameters to create every new map from that point. And it's just really readable, and it's reusable, so I don't have to type all that out every time, or copy and paste, which is also, you know, really error prone. Then next thing I want to show off is this next color. Maps to the get next color method that I actually created, but I don't have to call the getter because there's auto getters and setters. And then this is accessed. This is an example of operator overloading right here. So circle colors is this circle color manager, and it's not an array at all, but I'm able to use that index operator. And so if we check that out, I was able to do that by just making this method get at, and now Groovy recognizes that operator with the brackets, that this is the method I'm actually calling. On top of that, so the reason I wrote it this way is because the typed array in Java or in Android requires you to call getColor with the index value you want, and then if there's not a color there, to return some default color, which I didn't really want to do. I wanted to be able to access it as an array. And I didn't really want to have to think about what happens if there isn't a color there, because I know exactly how many there are. And then to make this object still pretend that it's a typed array, I had the delegate here. So every method that's on this type array is actually visible on Circle Color Manager, which is really nice too. I didn't have to write each individual method out and then delegate it to that class.
Question?
Yeah.
Okay, that's all cool, but why not just make a function call? I mean, why go to all the obfuscation of making it look like an array?
To make it look like an array?
Why?
I mean, part of this is just to show off some of the stuff you can do in Groovy. But on top of that, I wanted to be able to, like, this is much more concise than Circle Color Manager, whatever function call, and then have this in there. That was the whole reason I wrote it, is I had like, having that all in one block was really, really gross, and looked gross. So I wrote it out that way. Now you can see that I'm updating the index color, and then if it's bigger than this length, it loops back around and continues to get colors. So
Yeah, but why not have a function called getCircleColor? You call that.
that's what this is, getting the next color.
Yeah, but why does circle colors? Why make it an array? Why make it a function?
I mean, yeah, so
You do exactly the same code block in the parameter called the function as you're doing with all this.
that code block would have been in here, this colors.getColor at, and then you would have had the code, can't make that go up any further. That code block would have been in here. So again, part of this was just to show off some of the stuff you can do in Groovy. But yeah, it looked like this was a lot of extra code I wrote to get that, but I still do think that it looks nicer. Another thing to show here is that Android Studio doesn't fully support knowing all of the Groovy stuff, so it doesn't think that the circle colors is actually a thing. When it is, it'll compile just fine.
So does it do some of the autocomplete, as you're typing for?
Yep. Yeah, so it recognizes Groovy. It's just certain like generated files like that from Android that it doesn't recognize. It's using IntelliJ 13, I believe, behind the scenes. Android Studio is. I think they're working on getting 14 there, which will add a lot more support for some of this stuff. Since 13 didn't know about Groovy 2.4, so if you try to use like traits right now or anything like that, it won't work. So here's that map constructor that I was talking about. I'm overriding the default one. Something to note here is I have to call as float because Groovy's default number values are either big integers or big decimals, which is both nice and kind of a pain. You only have to call as float because I'm doing static compilation. Here's my click listeners, so I'm just returning a closure rather than writing a new view or on click listener. And again, because of the static compilation, you have to do the as. Unfortunately, I'm sure a Groovy developer who's been doing this longer than me could probably write some cleaner code, but this is what I came up with. And I think that's really all I have to show in this project. Awesome mouse.
Do you have the game?
What's that?
Do you have the game
Do I have it?
to see?
Yeah. Let me get Jenny Motion up and running. Oh, throw it on there. used, it doesn't reset properly, and I think my speed values are kind of off. So this is on GitHub. It's not in the Play Store yet, but when I get some more free time, I will update it and get it out there. Reset. As you saw, I got like 3 game overs in there, but yeah, that's the game. It's pretty simple, which is why I chose to do it. So, in closing, like Android has a lot of issues, kind of painful issues that are, you know, spawned out from just kind of never breaking backwards compatibility. It's a pain. But, and Groovy doesn't, or switching to any language, I've looked at a bunch, like Scala, Kotlin, and Groovy. None of them actually like fix any of the inherent problems that Android has, but they do great, Groovy is a great tool to kind of smooth them over. It just makes it a lot less painful. Anytime I go from Groovy development back to Java, oh yeah, this is just painful, I forgot about this. So, I like to recommend checking it out, trying it out. And you guys have any questions? Yeah.
So what do you think of Groovy versus Kotlin and Scala?
So I haven't played around with Kotlin nearly enough to be able to comment on that one. But Scala, I just thought it was I thought it was fun. I have a web app written in it, but I don't know. I guess I liked Groovy more just because it's so flexible with what you can do. Like, don't get me wrong, you can shoot yourself in the foot very easily if you want to or choose to make poor decisions. But yeah, I just felt like it was a lot. Like, I just like it better. I can't give you a better reason than that.
That's fine.
Yeah.
Have you seen any compatibility issues with older devices and newer devices with things that do work and don't work?
Not device-wise. I know I was having issues with certain compilation on Genymotion's x86. I was having some weird issues with compilation on that, but I don't know. It seemed like that was a known Android problem with something I was calling rather than a Groovy problem. And then some stuff I've seen with abstract syntax trees, transformations. I've seen some code generated that's not valid when it's converted to dex, so you get like a verifier. I've seen that happen as well, but I've never haven't had any compatibility issues. Yeah.
How does compiling Groovy affect your APK size? I mean, does it have to throw in all the Groovy libraries and all that?
Yeah, so that's a great question. It definitely makes your APK significantly larger. It's recommended to run ProGuard to bring it down because you're probably not using all of the things that Groovy offers you. But it's still, Cedric has in one of his talks some sizes of like what it was and that kind of stuff, and it wasn't huge. There, I think it was like 4 megabytes was this simple app for GradeConf. So it's like what its ending was. You're more likely going to hit the 64 method limit before you make your APK size too large from adding Groovy. Cool. Well, I'm gonna post these slides and that other stuff up to GitHub.